Time for earthquakes. An earthquake in your backyard, is that direct or indirect evidence that the earth is changing? Well, since your house is falling apart and the plates are falling out of the cupboard, yeah, pretty direct evidence. By the way, later on we're going to talk about plate tectonics. There was once a question on the exam that said, what is the connection between earthquake activity and plate tectonics? And actually, the earthquake activity is evidence of the plates moving. But the student's answer to that question on the final exam, in the case of an earthquake, you should make sure that all the plates are locked in the cabinet. Make sure you don't answer like that on the final exam. Anyways, let's talk about earthquakes. Guys, one of the things on the final exam you're going to have to do is take earthquake data and utilize it to basically find a quake. Earthquake. You got to find where the earthquake is. There's actually two locations we identify when it comes to earthquakes. The epicenter, like epithelial cells with your body. Epicenter means the outside, where it occurs on the surface. That's what we're really concerned about. The focus is where scientists are concerned because that's actually where it occurs, either in the case of San Andreas, where sometimes the epicenter and focus are the same, or typical, where focus is well beneath the surface, the actual place where the fault movement occurred, where the earthquake action emanated from. But the epicenter is the part that we're going to locate. We saw a little video on that. We saw a video on triangulation. The really important part, I'm going to hammer home here, how many signals do you need with an earthquake, earthquake seismograph stations pick up in order to find where an earthquake is going to be? And the bottom line is you need at least 3. Because once again, the situation has to be triangulated, which means you have to have 3 circular distances, and those 3 circles drawn will cross at one particular point. If all you have is 2, the circles will intersect twice. It doesn't narrow it down. You have to have at least 3. The reality is when an earthquake goes off on the planet, thousands of earthquake centers pick it up and deliver this information, of course, via satellite, via computer today, that we can pinpoint if this thing occurred in your closet, in the closet of your room. We can really, really nail it down as to where this earthquake happened. Now, this is also part of your lab final. So guys, I'm really hoping that I'll see you before that occurs in the classroom. But if that doesn't occur, I'm sure New York State is going to have some type of variance as this thing continues to evolve very, very much day to day. All right, so let me show you an earthquake chart, earthquake data. First of all, an earthquake went off someplace on the planet. And in this case, we had an earthquake station in New York, Mexico, Denver, Quebec, and San Francisco pick it up. And this is the clock down here. We use military time when it comes to these things. So 1500 hours is actually 3 o'clock in the afternoon because 1200 hours is 12 noon. 0 hours is midnight, or you can also say 2400 hours for midnight. Both ways works. So this is actually 15 hours is 3 o'clock, and that's 45 minutes. So that's 45 minutes after 3 o'clock. This is the P&S wave data. So this is how it looks when it comes into a seismograph machine and produces this thing called a seismogram. Let's pick on the first 3. Let's pick on New York, Mexico City, and Denver. First change in the wave action, because here it is, the first change is the P wave. P waves are always faster than S waves. So it takes a while for the next change to occur, which is the S wave. And we can identify all of these as P and S. Now, let me show you how this works. Very simple. Very simple. Let's say my nose, the tip of it, is where an earthquake has happened. Now, this is the P wave right here. This is the S wave traveling throughout the earth. P waves are primary. They're coming out first, and they're fast, and they're pulsed. They move like this, like a bullet shooting. S waves spend all their time going sideways. They're slow, they're sheer like scissors, they're secondary. Everything about them is S. Now, here's the big deal. Let's just say a P wave is about twice as fast as an S wave. So after 1 minute, let's say the P wave moves 2 steps, the S throughout the earth has moved 1. Another minute goes by since the earthquake. P wave 2 steps, S1. Another minute has gone by. P waves and S waves continue to voyage throughout the planet. P wave 2 steps, S1. Obviously, what keeps happening to the distance between them? The P wave is moving further ahead, further ahead, further ahead. And in between them is developing a greater distance and time gap. Here's the deal. The greater the time gap between the P and S wave arrival, the farther away the earthquake is. Now, it's pretty difficult to tell the difference in the gap between the P and S wave in New York City and Mexico, okay, Mexico City. But look at Denver. There's the P wave, there's the S wave. You see how there's less time gap between them? Question on the final exam. There's 3 cities that pick up an earthquake. Which city is, snap, closest to the earthquake? Denver. Denver's closest to this earthquake because it had the smallest gap between the P and S wave arrival. Now, let me show you a chart that shows that. So here's a chart on page 11 of your reference table that has to show how we read this stuff. And oh my gosh, this is really not hard. It really isn't. If you're at the actual site of the earthquake, and let's say an earthquake goes off in Buffalo, and they pick it up at Canisius College, where they have this amazing seismic recording station. The P wave's going to arrive, and like less than a second later, the S wave's going to arrive, and your next move should be out the door. Because that means if you get the P and S wave on top of each other, that means the earthquake is underneath you. Well, what happens to the gap between the line of curve for S waves, which are slower, versus P wave as time and distance go on? The gap gets greater. The gap is greater, showing that you are farther away from an earthquake. For instance, if I do this right here, if I say, okay, what is the gap right here? There's a nice gap. Approximately how much is that gap? Well, it's about, and we're going to learn how to read this chart, these things go by 20 seconds. That's 8 minutes, 20 seconds. That's 8 minutes, 40 seconds. That's 8 minutes, 60 seconds, which of course is 9 minutes. All these go by 20 seconds, all these little ticky poos. Now, all these marks at the bottom, they go by 200s. These are distance. This is not a 1. This is 1,000 kilometers because it says that on the reference table times 10 to the 3rd kilometers. That's 1,000. So that's 200, that's 400, that's 600, that's 800, that's 1,000, etc. 1,200, 1,400, 1,600. Let's go back to this. Let's say the city is 8 minutes and 20 seconds after the earthquake, the P wave arrives at the seismograph. It gets picked up at that city. Let's call it the city of Timbuktu. Okay? Now, the S wave didn't show up until 15 minutes after the earthquake. So how much gap is it between 8 minutes and 15 minutes? Well, it's obviously, that's 7 minutes worth of gap. Okay, and now we want to measure, well, how far away would the earthquake be if there were 7 minutes worth of gap? We use a spare sheet of paper. My paper is highly reliable and not too flexible. You guys might use an index card. And I'm measuring off this gap. You see how I did that? I measured off that gap. And now, what I'm going to do is I'm going to put it on the side and we're going to show that that gap was indeed about 7 minutes and 40 seconds, okay, of gap. And how far away is the earthquake when you have a gap like that? The earthquake is right there. The earthquake is 5,000 kilometers away. So if we know the gap of time, of course this time I plotted the gap of time, but if we know the gap of time, we know how far away the earthquake is. Let me show you. So we're just going to do one of these because we don't have time to do more. Of course, how many stations do we need to find out where the earthquake is? We need at least 3. 2 will tell us how far. 2 will tell us when it started. 2 might tell us relatively how powerful it is, but 2 will not tell us where. We have to have 3. So let's do this. The P wave arrived in New York City right there. Right there is, it arrived at 15 hours, 45 minutes even. Now we're not going to worry about the hours until the very end. We worry about origin time. So we're just going to worry about the minutes. We're going to say the P wave arrived at New York at a 15-minute, it looks like right on 45-minute, arrival. Now, what time did the S wave arrive? we look down on the chart, and we look straight down from the S-wave, and the S-wave arrived at 52 minutes. 52 minutes. So how much time gap is between 52 minutes and 45 minutes? Hopefully you don't need a calculator. It's 7 minutes of time between them. Now, if there's 7 minutes of time between them, how far away is the earthquake? We have to use the chart. Once we have the time gap, this is my saying. We must measure along the side and slide. We have to measure along the side and slide. So the first thing we have to do is measure how big a 7-minute gap would be. Why 7 minutes? Because that's the time gap between the P wave and the S wave arriving. Pretty close to our first example. So in fact, almost exactly, let's measure off 7 minutes. There's 7 minutes, 7 minutes of gap. And we slide this up until we find, no fair tilting, where the two lines are 7 minutes apart. I'll be sending you guys a worksheet on this, and once again, we already did this, so we know what it's going to come out to be. It's going to be 5. 5 what? 5,000 kilometers. So we go over here, and we put down that it's 5,000 kilometers away. I'll multiply that by 0.62, and it'll tell you how many miles. We don't have to know that. And now, how long does it take a P wave to go 5,000 kilometers? You could be asked this on the exam. How long does it take a P wave to go? 5,000 kilometers. Let's see. All right, so we go up from 5,000 kilometers until we hit the P wave. You got to listen. This is how it works. It's going to go up. Ready? You land right there. You go over, and you're one little ticky poo above 8. That means it takes 8 minutes and 20 seconds for the P wave to make that journey. Once again, you go up from 5,000 until you hit the P wave. You go over. It takes 8 minutes and 20 seconds for the P wave to make that journey. So we say P travel time is 8:20. Now here's the deal. The P wave actually, the P wave arrived at time 45 minutes. Now watch me. It took 8 minutes and 20 seconds to get to New York. So the P wave went off with the earthquake right here. It took 8 minutes and 20 seconds to get to the earthquake, or to get to the seismograph. So if it took 8 minutes and 20 seconds to get to the seismograph, and it arrived at 45 minutes after 3 o'clock, because 15 hours means 3 o'clock. So we'll put down the 15 hour. What time did the earthquake start? 8 minutes and 20 seconds before that time. So what's 45 minus 8? It's 37. 37 minutes and 20 seconds, so it's actually 36 minutes and 40 seconds. So the earthquake actually started. This is 3 o'clock. 1,500 hours is 3 o'clock, just like 1,200 hours is 12 noon. It started at 36 minutes and 46 seconds after 3 o'clock by doing this travel time subtraction. Let me just show you one more. We'll just do one more. Again, we would need all three in order to get where the earthquake is. Let's do Denver. Okay, let's do Denver next. Okay, so there's Denver, and the P wave arrived, oh my gosh, right on 43 minutes. You guys see that? 43 minutes. P wave arrived right on 43 minutes. Now, the S wave arrived right there. Let's mark it off. The S wave arrived a little bit before, halfway between 48 and 49 is 48 minutes and 30 seconds. So that's about 48 minutes and 25 seconds. 48:25. Okay, guys, how much time is it between 48:25 and 43? Isn't that 5:25? Let me take off my shoes and use my toes. No, it is. It's 5:25. All right, so now what do we have to do? Once we have a time difference, that's supposed to be a 5. Once we have a time difference, we have to measure along the side and slide. So we take our chart. Now we have to measure 5:25 along the side and slide. So here we go. I'm going to use that fat line as my start point. There's 5. One little tick up is worth 20 seconds. So 25 is barely above that, because halfway would be 30 seconds. So there it is, 5:25. Measure along the side and slide. No fair tilting. Keep it straight up. You guys are going to have to do this on your own. Really do it on your own. Even though you're out of school, you got to do it on your own. I look straight down. I'm 3 lines past the 3. 3,200, 3,400, 3,600 is the distance. So I put down a distance of 3,600 kilometers. Question on the exam. Well, 2 questions. First of all, if there's 5 minutes and 25 seconds of gap, how far away is the earthquake? We just did that. How long does it take a P wave to travel? 3,600. Let's see. Once again, you have to listen. You're at 3,600. Here it goes. Halfway between 6 minutes and 7 minutes. Is that 6 minutes and 50 seconds or 6 minutes and 30 seconds halfway? This is time, not a dollar bill. It's 6 minutes and 30 seconds. So the time gap is 6:30. 6:30. Okay. Now, the P wave arrived at 43 minutes. It took 6 minutes and 30 seconds to get to Denver. Question is, what time did the earthquake leave? Well, what is 43 minus 6? It's 37, isn't it? Minus 30 is 15, 36, 30. Houston, we have a problem. The earthquake only started once. We're not talking about aftershocks here. These origin times at the end should be the same. They should be the same, but they're not. The reason they're not is because I did not perfect my ability to subtract and assess time on this chart. In other words, there's some Critelli, also known as human error, involved in this process. Here's the thing. If those don't come out close, if they don't come out within a minute of each other, you did mess up. Something is seriously wrong. Well, mine are only 10 seconds apart, so I know I'm pretty good. Now, if I had a third station, let's say that was 4,000 kilometers away from the earthquake, and I took all those stations, New York, Denver, and let's just say San Fran. Let's say the other one is San Francisco. And I was, let's say, on a United States map. Let's say here's my United States map. Sorry about the crude nature of this map. There we go. There's the United States. Also looks like a cow with its head cut off. All right, and here's New York. They picked up the earthquake. Here's Denver. They picked up the earthquake. And here's San Fran. They picked up the earthquake. And once again, I know this is a lot confusing. You're looking at, okay, 5,000 kilometers from the earthquake. Denver, 3,600. And I'm dying. I'm not really. Okay, and San Francisco, 4,000. So here we go. You got 5,000 kilometers away for this earthquake from New York. You make a circular distance with a protractor like that. Actually, drawing compass would be even better than a protractor. Critelli, get your instruments correct. In fact, we could use a weapon of math destruction to build this. Okay, then we do the distance of 3,000 whatever from Denver. Okay, like that. And then we're going like 4,000 away from San Francisco. I know it's a little lopsided. Anyways, where the 3 circles meet is right there. See, if all I had was Denver and New York, it just would have crossed twice. But that plots the epicenter, and that, ladies and gentlemen, is what you're going to have to do. Now, what do these earthquakes show? These earthquakes show that the earth is moving. What's next? Plate tectonics.